Ladies and gentlemen, hello and welcome, coming to you once again, not quite live from One Take Studios, where we are still in the world of mystery and intrigue. Today's topic is multiplicative ciphers. Okay, if nothing else, that's a fun word, multiplicative, you should say that out loud. With this, I previously did a video for additive ciphers, so I'm going to run with the assumption that maybe you've seen some of that. I'm not going to completely re-explain everything, but we are still working with monoalphabetic substitution ciphers, so basic one-letter substitutions of the alphabet to make things that are encrypted. Alright, secret code stuff. So, multiplicative, you can probably guess we're going to be multiplying some stuff today, and this gets interesting, so watch the details here, would you? Alright, so in order to create a multiplicative cipher, we are going to be multiplying, okay, you probably guessed that, multiplying the position of the plain text character by a number, which is the key, mod 26. Coming back to that. To find the position of the ciphertext character. Again, plain text is things that are not in secret code, usually represented by lowercase, and ciphertext are things that are in secret code, usually represented by uppercase for what we are doing here. So, here's the thing. You cannot just use any number as your key. So note to self, you can't just pick a number and go and expect this to be successful. You have to be careful. For example, let's say for the fun of it that the key was 4. 4 sounds like a nice number. I can multiply by 4, no problem. Okay, so the letter A, lowercase because we are in plain text, is the first letter of the alphabet. If I do 1 times 4, that's 4. Mod 26 just means that if I go past 26 at the end of the alphabet and I cycle back around, where will that put me? Well, still at 4. 4 is the fourth letter of the alphabet, which is the letter D. So using a key of 4, the letter A in plain text would be represented by the letter D in ciphertext. What if I take, the letter N, which is the 14th letter of the alphabet, and I do 14 times 4? Ladies and gentlemen, 14 times 4 mod 26 is also 4. What does this mean? Well, okay, 14 times 4, I can do this. 14 times 4 is going to be 56. Think about that, 56. How many times does 26 go into 56? Well, 26 and 26 is 52, and 56 is 4 past 52. That's where that's coming from. So this idea that after I multiply, basically I'm dividing by 26, and whatever the remainder is, that's going to give me my place in the alphabet, which sadly is still D. Alright, so if you're looking to be extra tricky, alright, this would do it, but quite frankly, this is unfair. If I see the capital letter D somehow, it's supposed to represent the letter A and the letter N, and I'm supposed to figure that out. Not a good idea. Alright, so you can't just pick any number here because sometimes you end up with the same letter representing two different ones. So what can you use for a key? This is important. Your key, I decided to use this in set builder notation, so the allowable keys. X, such that X is an odd number, so you may pick odd numbers. 4, if you notice, was even. That was problematic. But those odd numbers have to be between 1 and 25, including 1 and 25. Some of you may also currently be thinking, why would I use 1 as a code? You wouldn't. Multiplying by 1 doesn't change anything, but hey, you could use it. It would just be silly. Also, you have to exclude the number 13. So if you want to pick a key, you have to pick an odd number between 1 and 25, but you can't pick 13. But you can pick 25. That's how that works. Feel free to not trust me and try all other kinds of numbers and see what happens. Be careful, okay? Alright, so what does this look like? I'm going to get some calculator stuff here for you so you can see some of this mod stuff. The mod stuff is actually modular arithmetic, and your calculator will run with these. That means that I can do these and actually have the calculator spit out the remainders for me. So this would be great for computer programming if I wanted to set this up so that I'm not trying to decipher everything by hand all the time. Or, for that matter, encrypt it by hand. So let's say that our key is going to be 3 for this next example, which is an odd number between 1 and 25 and not the number 13. So that means simply that we would be multiplying each of these by 3. Yes, multiplying by 3. So 19 times 3, 20 times 3, 1 times 3, 25 times 3. Some of these numbers are going to be bigger than 26. So what am I going to do? Well, let me show you. Alright, so switching to my calculator screen, I can actually type in the word mod, and that's a built-in program. Oops, or I should actually get myself on the screen first. There we go. I can type in the word mod. I said I can type in the word mod. Oh, lordy. Okay. And this will be recognized. Now, there are two arguments, two things that you're going to put in parentheses that are going to run with this mod program. The first thing could be a number or a calculation. So I could do 19 times 3 myself, or I can say, hey, calculator, can you please do 19 times 3 for me? And the calculator would be so kind as to actually take care of that. So we're saying 19 times 3, whatever that total is, I want you to wrap back around after you hit 26. Again, other rough translation with that is 19 times 3 divided by 26, what will my remainder be? Hit enter. Ladies and gentlemen, that means that we are going to get 5, the 5th letter of the alphabet, which would be the remainder after we finish dividing. And that means that the 5th letter of the alphabet is going to be the one that now represents, where'd it go? Represents S. Sorry, I'm making notes to myself, so when we come back to my other screen, I will have a 5 written down. So the 5th letter of the alphabet will represent the 19th letter of the alphabet. That was so much fun, we should do it again, but we don't have to even go back and retype everything. We can just go back and grab this and edit. Instead of doing 19 times 3, I'd like to do 20 times 3 this time. Again, mod 26, because the alphabet still has 26 letters. So that's going to be taking the 20th letter here and representing it as the 8th letter of the alphabet in our secret code. Again, just bring this back up and we can edit. I really don't want to edit 1 times 3. I'm pretty sure I can figure that one out. But for the fun of it, I am going to put the 25 in here. We'll pick that one up. And so that's going to be 23 for the remainder. All right, so again, wrapping around after 26 in the alphabet, coming back around and figuring out what we're going to have. Coming back to my other screen then. Eeny, meeny, miny. There we go. All right, so with the mod 26, this is 5, this is 8. 1 times 3 is simply 3. I don't need to worry about that one. That one's fine. But this, again, is the remainders after we take the 26s out of the cycle, after we multiply by 3. So that means that the 5th letter of the alphabet is A, B, C, D, E. Every time I have S and I want to put the letter S into secret code, I'm going to use a capital E. So again, I'm taking the word stay, simple word, but gives me enough variety here to see it. And the S will be represented by E. 8. What is the 8th letter of the alphabet? Consulting my list, the 8th letter of the alphabet, sorry, I almost dropped my paper, is H. So T will be represented by H. The 3rd letter of the alphabet is C, so A is going to be represented by C. And the 23rd letter of the alphabet is W. So if I'm taking the word stay and I'm putting it into secret code, it's going to look like this. E, H, C, W. That is my secret code. Again, would I look at that and think, I think that's the word stay? Probably not. And the exciting news is that this is actually a little bit more difficult to take apart than additive, so this is a little bit less likely that somebody's going to figure this out. Can these things get really complex? Of course they can. This is just an introduction to fun and exciting topics, in my opinion. All right, are you still paying attention? Not only can we not just use any key, but deciphering is interesting. How do we take these things back apart again? All right, so there we go. You're going to take the key that you used. You're going to multiply that key by other keys in this set until you find its match, essentially, until you find the key that when you multiply it with the other allowable key, mod 26 will get you a remainder of 1. You want it to equal 1. So my key was 3. And if I look at this and say, all right, 3, if I start multiplying by different numbers in this set, it just so happens that 3 times 9 is 27, which mod 26 has a remainder of 1. That means that if I had a key of 3 here to begin with to put things into text, I want to use a key of 9 to take things out of text. So 9 will take things apart. That's the key I want to use to decipher this. By the way, for those of you thinking, well, 9 times 3, 3 times 9 is the same thing. These two are a matched set. They are a pair. If I use 3 to put things into secret code, I can use 9 to take it out. Vice versa. If I put 9 to put things into secret code, I can use a 3 to take things out of code. So these two help each other out. They're nice complements to each other. Which means if I'm taking my EHCW and saying, somebody told me that the key was 3. I'm going to decipher this. I'm going to multiply by 9. So again, times 9, times 9, times 9, times 9. And these are, again, bound to represent values that are larger than 26 in many, many cases, or all cases. in which case we want to again do the mod 26, and what's the remainder? If we pull all the extra rounds of 26 out of there, what is going to be left? So again, I'm going to jump back to my other screen. There we are. And again, I just want to jump back up into what I had because I don't want to retype everything, and I don't have to. So this time, what am I doing? Still mod 26, but I'm doing 5 times 9. So we will back that up a little bit here and do 5 times, there we go, 9. And there we go. So 5 times 9 mod 26 is 19, so that would have a remainder of 19. Jotting that down. There we go. And back up again, grabbing that the second time through. We're doing 8 times 9, so just editing what I have, working smarter. Enter. That's going to be the 20th letter of the alphabet. 3 times 9 is 27. You know what? I'm going to go ahead and say I can figure that one out again. I'm not going to retype it. But let's go ahead with this last one, which was 23. So 23 times 9 mod 26 is 25. Handy things, calculators sometimes. Again, spreadsheets are really nice for this stuff too, actually. Alright, so I said I could figure out 3 times 9 is 27. That is one number past 26, so there we go. And if I look at my numbers from before, I can see that I've successfully decoded this. S is the 19th letter, T is the 20th letter, A is the first letter, and Y is the 25th letter. Alright, so the exciting part comes to be when you don't know the keys at all. But again, we have to start someplace, so be careful, watch the details with this, and again, the biggest thing is, can you do this without making an error? It is so difficult to do this focused without making mistakes anywhere, especially when you're just doing more than a simple 4-letter word, like you have an entire sentence perhaps, or something crazy like that. So keep your eyes open, keep your ears open, and seriously, just enjoy this stuff, alright? Thanks!